Let's check exercise 7. In a certain company, the employees working in project X and project Y, which have no common members, will combine to work in project Z. Are there more members working in project X than in project Y? We can just label X and Y the number of members in each project. The sum of them would be Z, the total number of members in both projects combined. They're asking us if X is greater than Y. Statement 1 says that the average annual salary, okay, that is the sum of salaries in X, okay, divided by X would be 95K, and the sum of salaries in Y divided by Y, which is 115K. But here we have no way to know the relationship between X and Y because we don't know the sums, so not sufficient. Number 2 says that the average arithmetic mean annual salary who will work in project Z will be 98. So these two sums of salaries divided by the total number of employees is 98K. But that itself doesn't tell us which X or Y is greater than the other. What about if we combine the two of them together? If we combine, we can see that the average of 98K is actually like a weighted average of 95 and 115. If we put it here, the difference would be 3, the difference would be 17. Here the weight is X, the weight is Y, the number of members for each project. So we have like this inverse relationship, X is to Y, like the difference 17 is to the difference 3. Okay, so X is to Y as 17 is to 3, 17K to 3K. So obviously X is greater than Y. Sufficient, and that is option C. Okay, so that's one application of the weighted average concept.